For our project, we did what is the best predictor of success for a college basketball team. For this project, we got to collect data on any subject of interest that we wanted to. My partner and I chose to look at different variables that would determine success of basketball teams, with success measured as regular season wins. Our sample teams were the last 20 national champions. The variables we used to compare for these teams were their strength of schedule and average points per game. Both of us predicted that points per game would more accurately show a team's success, meaning they would more accurately show the higher regular season win percentage. This is our data. Some observations we had were many of the championship teams had 26 regular season wins. The lowest recorded strength of schedule is 5.49. The least amount of regular season wins from a championship team in the last 20 years is 19. Kentucky had the most regular season wins in the group, only losing one game. Only 2 teams in the group had averaged more than 90 points per game. 3 out of 5 of the teams with the highest strength of schedule were still at the top of the data set. The teams with the second highest strength of schedule also had the least wins of the group. The highest strength of schedule from this group of teams was Duke in 2001 with 11.97. All of these teams had a compact range of points per game. The standard deviation is 5.9. 5 teams from this data set have repeated titles in the past 20 years: Duke, UConn, North Carolina, Kentucky, and Florida.
For our first graph, this is showing how strength of schedule correlates to a team's success, which is measured by regular season wins. For this graph, there is a weak positive correlation between the data. This is because there is no pattern in the graph, and it also does not form a line. It is not linear. We can also determine that this is a weak positive correlation by the R value. Since the R value in this graph is so close to 0, we can determine that there is a weak correlation. The equation for this least squares regression line is y equals negative 0.323x plus 28.3, and the R squared value is 0.036. For our second graph, this is showing the relationship between average points and a team's success. For this correlation, there is also a weak positive correlation for this graph, as it is not linear, and the R value is very close to 0. The equation for this least squares regression line is y equals 0.0956x plus 17.6, and the R squared value is 0.055. For our numerical summaries and interpretations for strength of schedule, the equation is y equals negative 0.323x plus 28.3. It has a standard deviation of 1.425, has a R squared value of 0.036, and there is a weak positive correlation present in this relationship. And for average points scored, it has the equation of y equals 0.0956x plus 17.6, has a standard deviation of 5.941, the R squared value of 0.055, and it also has a weak positive correlation. For a 5-number summary of these two relationships, for strength of schedule, it has a minimum of 5.49, a Q1 of 8.35, a median of 9.21, a Q3 of 10.06, a max of 11.97. For average points scored, it has a minimum of 71.8, a Q1 of 77.2, and a median of 79.6, a Q3 of 85, and a max of 91.4. So for our conclusion, an NCAA champion basketball team obviously has a lot of pieces that fit together to make it work. So with only 2 of these possible factors, it would be nearly impossible to get a strong correlation, or in other words, say that one thing is the reason why a team is so successful. So after collecting all our data and making our graphs and tables, we concluded that strength of schedule was a better predictor compared to points per game, or average points scored. We think that strength of schedule is a better predictor for a team success, which is measured by average wins.